A big hi to all of you. So today let's start with the third part of our discussion on the p block elements, that is going to cover group 15, 16, 17 and the noble gases. So let's start with the important characteristics of the elements of group 15. Group 15 consists of nitrogen, phosphorus, arsenic, antimony and bismuth. This group is also known as the nitrogen family because nitrogen is the first member of this group. Another common name of this group is Pnictogen family. The electronic configuration of these elements in their valence shell is ns2np3. So they can gain stable noble gas configuration either by gaining 3 more electrons from more metallic elements or by sharing 3 electrons. Now let's have a look at the physical state of these elements, in which these elements usually occur on the earth, the various forms in which they are found, and their abundance in the earth's crust and the earth's atmosphere. The first member of this group is nitrogen. It is a colorless, odorless, inert gas. It is the 5th most abundant element in the universe, and it constitutes around 78% of the earth's atmosphere. Its abundance is 19 ppm in the earth's crust. The second element of this group is phosphorus. Due to its very high reactivity, it is not found in its native elemental form on the earth. It usually occurs in the form of inorganic phosphate rocks. It is the second most abundant mineral in the human body, and 85% of it is concentrated mainly in teeth and bones. Its abundance is 1050 parts per million in the earth's crust. Next element is arsenic, which is found in its elemental form as well as combined with sulfur and other metals. Its abundance is 1.8 ppm in the earth's crust. Next element is antimony, which usually occurs in the form of sulfide mineral stibnite. Its abundance is 0.2 ppm in the earth's crust. Bismuth, although it occurs in its elemental form as well, its important economic sources are in the form of sulfide and oxide ores. Its abundance is 9 parts per billion in the earth's crust. Allotropy is exhibited mainly by phosphorus, which occurs in 3 important forms: white phosphorus, red phosphorus and black phosphorus. The most common allotropic form of phosphorus is white phosphorus, in which P4 molecules are found. In each molecule, the atoms are arranged in a form of tetrahedron with the bond angle around 60 degrees. It is the most reactive form of phosphorus, and when exposed to air, it inflames automatically. It also exhibits the property of chemiluminescence. The next allotropic form is red phosphorus, in which long chains of phosphorus atoms are found, which are covalently bound to each other to give a giant molecular crystal structure. Red phosphorus is stable in air. Next allotropic form is black phosphorus. It is the most stable form of phosphorus. Its crystal lattice consists of double layers. Each layer is made up of zigzag chains of phosphorus atoms, and the bond angle is around 99 degrees centigrade. Black phosphorus shows striking structural similarities with graphite, which also has a layered structure and also exhibits moderate conductivity for heat and electricity. Oxidation states. The members of group 15 exhibit +3 and +5 oxidation states, which are the most common oxidation states. They never form ions of the type M5+ because of the small size and high charge density on such ion by losing all their electrons in their outermost valence shell. Although antimony and bismuth form M3+ ions due to their low ionization enthalpies. Nitrogen and phosphorus exhibit various oxidation states from -3 to +5. Being smallest in size, nitrogen has a tendency to accept 3 electrons and form N3-, that is nitride ion. Phosphorus also forms such similar phosphide ion, but not with the same ease. Other elements do not have any tendency to form triply charged negative ion. Nitrogen shows a great tendency to form p-pi multiple bonds with other nitrogen atoms as well as with carbon and oxygen. But this tendency shows a marked decrease as we move down the group. If we look at the electronegativity values of group 15 elements, we found that there is an expected decrease in the value as we move down the group from nitrogen to bismuth. However, as compared to the group 14 elements, group 15 elements are more electronegative. If we look at the atomic, covalent and ionic size of these elements, we will find that they increase on moving down the group as is expected with the addition of a shell at every period. In terms of covalent radii, there is a considerable increase from nitrogen to phosphorus, but this increase decreases as we move further.